Hello students, this is a video on the quant topic test available on the Bodhee Prep app. Basically, the idea of these tests is once you've gone through the concepts of a topic, you want to check for yourself whether you're able to do the questions or attempt questions on the topic or not. That is when you write these tests after completing a topic. With every test, there is a video which gives you a brief idea of this gives you the solutions for sure, and definitely a brief idea of how the paper should have been attempted in terms of level of difficulty and time. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description of this video. So make sure to download the app and make the most of these tests. This video is on solid geometry, 3D mensuration, and this is the fifth test that we are discussing. Overall, the test was about moderate level of difficulty with 6 questions net correct out of 10 in about 23-24 minutes, ensuring a 95 plus percentile. If we look at the questions says sum of the radius and height of a cylinder is 19. The total surface area of the cylinder is 1672. Now the total surface of your surface area of a cylinder is nothing but 2 pi r into h plus r. This is given as 1672, which means 2 into 22 by 7 into r. H plus r, the sum of radius and height is 19, is 1672. So from here we'll be able to get the value of the radius. 2 will cancel out. 8, 4, 3, 6. Again, cancel by 2, 11, 4, 1, 8, divide by 11, 38, divide by 19, 2. So r becomes 7 into 2, 14. Since r is 14 and we know that the sum of height and radius is 19, r is 14, so h will be 19 minus 4, 19 minus 14, which is 5. What we have to find out the volume of the cylinder. Volume is simply pi r square h, so 22 by 7 pi r square into h. 7 2s are 14. What we can do now is we can calculate 22 into 4. 22 into 14 would be 2 into 11 into 14. This will be 154 into 2, which is 308. This is 308, this is 10, and therefore the volume becomes 3080 meter cube. Option A. A bit of calculation, so I'm saying moderate, but about 1.5 to 2 minutes to solve. A hemispherical ball is 176 centimeter around the brim. Hemispherical bowl. Round the brim is 176, so we can say that the circumference of the top is 176. The top will be a circle with radius r, and therefore we can say 2 pi r is equal to 176, which means 2 into 22 by 7 into r is 176 for the hemispherical bowl. 22 and 176 will be 8. 2 4s are therefore 2 pi r, 2 pi r, 2 pi r. R will be 28. Supposing it to be half full. If this is half full, the volume that it will have is half of the hemisphere. Hemisphere is 2 by 3 pi r cube. 2 by 3 pi r cube. 28 into 28 into 28. This is the volume that will be there in the hemispherical bowl. How many persons may be served from it in hemispherical glasses? So from here it is poured into hemispherical glasses as well, which have 4 centimeter diameter at the top. So if the number of people that can be served is n, this total volume will be put into n hemispheres. The volume of the hemispheres will be 2 by 3 into pi into r cube. Since diameter is 4, radius will be 2. We have to solve for n. Clearly 2 by 3, 22 by 7 will get cancelled out. N will be nothing but 28 by 2, 28 by 2, 28 by 2. So half of 28 by 2 is 14, 14 and 14. At this point, it may not be a bad idea to simply use the product, the cube of 14. Cube of 14, as I remember, is 2744. And therefore, half of 2744, which will be 1372. And therefore, the number of people who could be served will be 1372, option C. Again, total volume of material present in the hemispherical bowl is equal to n into volume of a hemispherical glass. Find the value of n. Conceptually not very difficult. It's just that we have to be very sure about the half that is there and the diameter that is mentioned. So that also has to be divided by 2. So I'm saying moderate. Silly mistakes can happen. About 2 minutes to solve. A tent is in the form of a right circular cylinder. Right circular cylinder surmounted by a cone at the top. What will happen for the cylinder and cone is both will have the same radius, hopefully. The diameter of the cylinder is 24, and therefore the radius of the cylinder is 12. The height of the cylindrical portion is 11, while the vertex of the cone is 16 meters above the ground. If the vertex is 16 meters above the ground, we can say height of the cone will be 5, because this is given as 11. So total will be 16. The area of canvas required for the tent, this will be nothing but the curved surface area of cone plus cylinder. This is pi RL plus 2 pi RH. Pi R can be taken common, L plus 2H. So 22 by 7, radius is 12, L. Since this is 5, this is 12, this will be 13, right angle triangle. Or height, h square plus r square is equal to L square for a cone. So slant height is 13 plus 2h is 10. Height 10. H is this 11, sorry, 22. This becomes 22 by 7 into 12 into 13 plus 22 is 35, which is divisible by 7. 35. 5, 60. 22 into 60, which will be 1320 meter square canvas area. Option C. Again, conceptually not very difficult. We just have to find a slant height and put in the formula. So about 1.5 to 2 minutes. The sum of perimeters of the 6 faces of a cuboid is 72. Total surface area of the cuboid is 16. Longest possible length that can be kept inside the cuboid. Cuboid. If you look at a cuboid, there are 12 sides that are there. I am calling this length, this also length, and this also length. This is breadth, 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 breadth. The remaining is height, 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 and height. Now, if we look at the perimeter of the outer face will be HB, HB, twice of H plus B. This will be the same at the back, twice of H plus B. On the right hand side, it will be LLHH, so twice of L plus H. On the left hand side, twice of L plus H. Top will be twice of L plus B perimeter, adding just the length of the sides. Bottom will be twice of L plus B. So if we look at H, we have 2H, 4H, 6H, 8H. So if we add the perimeters, this will be 8 into L plus B plus H. Total there are 1, 2, 3, 4, 5, 6. Each term has 4 letters, H, H, B, B. So total 24 letters. Each letter is used equally. 3 letters are there, so therefore 8 into L into B, 8 into L plus B plus H. This is 72. So we get L plus B plus H is 9. Or you can simply add 1 by 1. If you look at B, 2B, 4B, 6B, 8B, and similarly L. Second is total surface area. Total surface area is 2LB plus BH plus HL. This is the formula that we directly have. This is given as 16. Therefore, LB plus BH plus HL is 16. These are the two equations that we get. We have to find the length of the longest possible length that can be kept inside the cuboid. The longest possible length that can be kept inside the cuboid is the diagonal across the opposite vertices, and it is root of L square plus B square plus H square. Now, root of L square plus B square plus H square will be nothing but root of L plus B plus H whole square minus 2LB, 2BH, 2HL. A plus B plus C whole square is A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Subtract it from A plus B plus C whole square to get A square plus B square plus C square. L plus B plus H is 9. Minus 2 into this is 16. This should have been 8, but anyways. So what we get is root of 81 minus 16, which is root of 65, 75, 81, root of 65. This will be very, very close to 64. And therefore the answer will be very close to 8.05. From the options, you can approximate. Because if you look at 8.1, 8.1 is more than 65. 8 is less than 65. So between 8 and 8.1 from the option 4. Again, rearrangement is required. Therefore, I'm saying moderate. Counting this might, there is a chance we might miss out on the overall values. And therefore, moderate about 2.5 minutes to solve. Radius of a cylindrical cistern is 10 meters. Height is 15. Initially, the cistern is empty. We start filling the cistern with water through a pipe of diameter 50. Water is coming out of the pipe with a velocity of 5 meters per second. How many minutes will it take? Now, the volume of the cistern will be equal to volume of water that comes through the pipe. Volume of the cistern will be pi r square h, which is 22 by 7. Pi will get cancelled out, but anyways. Radius is 10. 10 into 10 into height, 15. And this will be the amount of water that comes out through the pipe. That will be area of the cross section, which is pi. Diameter is 50, so r square, 25 into 25. Into the amount of water that comes in. Every second, 5 meters of water flows through. So if the time taken is n seconds, the amount of water that will flow through it is 5 into n or 5n. I am taking the time in seconds as n seconds. The length of the tube or the pipe will become 5n. Let us find the value of n. N will be meter, centimeter, centimeter. 25 centimeter will be 25 upon 100 meters. Meter, this is centimeter, so divide by 100. Let's see, so this will be 1 by 4 and not 25. So n becomes 22 by 7 is also cancelled. 10 into 10 into 15 into 4 into 4 by 5. So this becomes 60. 240, 480. 480, 4800. 4800 seconds. To convert it into minutes, we divide by 60. 4800 by 60, which is 80 minutes, becomes my answer. Option D. Again, conceptually not very difficult, just equating the volume. Calculation might take a bit of time, so 2 to 2.5 minutes. Aluminum sheet 27 centimeters long, 8 centimeter broad, 1 centimeter thick is melted into a cube. The difference in the area, surface area of the two solids would be. Now the surface area of the cuboid will be 2 into LB plus BH plus LH. Straight formula. 2 into 27 into 8. 27 into 8 is 160 and 160 and 50, 216. 216 plus 8 plus 27. 216 plus 8, 224 plus 27, 251 into 2 becomes 251 into 2, 502. The surface area of the cuboid is 502 centimeter square. Now, since this is melted into a cube, the volume will remain same. So we can say that volume of the cuboid, 27 into 8 into 1, will be volume of the cube. Suppose the side of the cube is S. This will be equal to S cube. So S cube should be equal to 216. We multiply 27 and 8. Taking cube root, S will come out to 6 centimeters. And therefore, surface area of the cube will be 6 into S square, which will be 6 into 6 into 6 into 6, or 216 centimeters square. The question is difference in surface area. The difference in surface area will be 502 minus 216, which is 302. If 200 is taken out, minus 16. 300 minus 1, 286. 286 centimeters square becomes my answer. 296, 300 to 500. Yes. And therefore, again, not a very difficult question. A minute and a half to solve. Only a bit of calculation is there. The rest is formula based. The volume and curved surface area of a cylinder, volume pi r square h, is 616. Curved surface area 2 pi rh is 352. What is the total surface area? To divide 1 by 2, pi r square h upon 2 pi rh is equal to 616 upon 352. Pi r h cancelled. 616, 352. 616 is divisible by 11. You factorize 616, 11, 5 are 55, 6. This is 8, 7. 616 is 11 into 2 into 2 into 7. If you look at 352, 352 will be divided by 2 becomes 156. 156 divided by 2 becomes 88. 88, 71, 176. 356 divided by 2 will be 352. Doing it again. 352 divided by 2 will be 176, not 156. This divided by 2 will be 88. This divided by 8 will be 11. So 2 into 2 into 8 into 11. 8 cancelled with 2 to 2, 11, 11 cancel. So basically R by 2 is equal to H by 7 by 2 into 2. 2 and 2 cancel. So the radius comes out to 7 by 2. Total surface area. We'll have to find H as well. 2 pi R into H. Actually, R is good enough. Now total surface area will be curved surface area 2 pi RH plus the area of the top and the bottom, which is 2 pi R square. Pi R square into 2. 2 pi R is given as 352. 2 pi R square will be 2 into 22 by 7 into 7 by 2 into 7 by 2. 7, 7 cancel, 2, 2 cancel, 2, 11. And therefore 352 plus 77 ends in 9, has a 2 in the sum. Therefore 352 plus 77, which comes out to 429 meter area square. Option A. Again, not very difficult. Only calculation part is there. About 2.5 minutes to solve. A plot of land is the form of a rectangle of dimensions 240, 180. Rectangle, dimension 240, 180. A drainlet 10-meter wide is dug all around its outside. And the earth dug out is evenly spread over the plot, increasing its surface level by 25 centimeters. The depth of the drainlet. Let the depth of the drainlet is D. We will use meters. I'm just drawing lines here so that it will be easy to calculate the volume. Now, volume of the earth that has been dug out will be equal to the volume of the earth that has been spread on the field. And therefore, we can say volume of earth that was dug out or spread on the field will be, let us not write it as D because it looks different. Let us simply write it as X meters. Here, base, length into breadth into height. The surface level rose by 25, so 25 by 100. Converting into meters. Length into breadth into height becomes the volume of earth on the field. This was taken out from the drain. The drain has width 10. What will be the volume of the drain? So first let's calculate the area. We'll multiply by the depth to get the volume. See, this part here will be 10 into 240. This will be 10 into 240. So this becomes 2400 plus 2400. This here will be 10 into 180, which is 1800. This will also be 10 into 180, which is again 1800. This here will be 10 into 10. So 100, 100, 100, 100, which is 400. This becomes the total area of the drainlet that has been dug. 48, 36 and 4, 488, 8800 meter square. Meter, meter, meter. Now suppose the depth is X, we can say the volume of the earth dug out from here will be area into the depth, and therefore volume of earth spread over the field should be equal to volume of the earth that was dug out from the pit drainlet. So area of drainlet into the depth. We have to find the value of X. X becomes 240 into 180 into 25 upon 8800 11 into 100. 25 4s are 100, 0, 0, 0, 0 cancelled. 4 6s are 24. 8. 3. 44. 9. 22. And therefore X comes out to 27 by 22. This is in meters. 27 by 22 meters. We'll have to find the answer till the third decimal point. This will be 22, 27. Basically 1 5 by 22. So 5 divided by 22 is what we do. 0.50 2s are 44. 6 0 2s are 44. 160. 7s are 140, 154. 6 0 2s are. And therefore this will be equal to 1.2272, or from the options 1.227 meters becomes the answer. Calculation is there. If we are able to work out the area of the drainlet easily, the solving time will not be very high, maybe 2 to 2.5 minutes, moderate level of difficulty. A hemispherical bowl, internal radius 12, contains liquid. This liquid is to be filled into cylindrical containers of diameter 4, height 3. Number of containers required is let's empty the bowl. The volume of the bowl should be equal to the total volume of the containers. Volume of the bowl, because it is hemispherical, will be 2 by 3 pi r cube 12 into 12 into 12. Suppose n numbers of cylindrical containers are used to empty this bowl. A hemispherical bowl, it is poured into cylinders. Suppose n cylinders are used. The total volume of the bowl should be equal to the total volume of the cylinders. Total volume of the bowl is equal to n into volume of one cylinder. Volume of cylinder will be pi r square. Diameter 4. Therefore, our radius will be 2 r square into height 3. All the sides are in centimeter. So we solve for n from here. Pi and pi cancel. 3 fours are 12. 2 twos are 4. 3 fours are 12. N comes out to 12 into 4. 48 into 2, 96 becomes the answer. Straightforward question, basic calculation, easy question. About a minute and a half to solve. If three metallical spheres of radii 6, 8, and 10 are melted into a single sphere, the diameter of this new sphere, radius for the first three were given. The volume of the single sphere will be equal to the volume of the first sphere plus second sphere plus third sphere. Volume of the first sphere will be 4 by 3 pi, 6 cube, 4 by 3 pi, 8 cube, 4 by 3 pi, 10 cube. Volume of spheres. Therefore, the overall volume here will be 4 by 3 pi, 6 cube, 216, 8 cube, 64 into 512, 7 512 plus 10 cube 1000. This becomes 4 by 3 pi. 216, 512 is 7281. 1728. This is nothing but 4 by 3 pi 12 cube. And therefore, we can say that the volume of the new cube is 4 by 3 pi 12 cube, which means radius of the new cube is 12. We have to find the diameter of the new sphere, not cube. The sphere, the diameter will be double of 12. That is 24 centimeter becomes my answer. Basic question, maybe a minute and a half to solve. And therefore, if you look at the overall test, easy to moderate level of difficulty, 6 questions in about 23-24 minutes. My 6 questions would be 1, 3, 5, 6, 9, 10. Which are these? This I think was an easy question to solve, formula based. I am not considering this one as one of the 6 because hemispherical bowl to the brim half full, so there are chances of a silly mistake happening. This I think was straightforward. Easy calculation as well. This I think was a tricky question. Finding the perimeter of the 6 faces, there is a very high chance of missing out on the exact number and therefore not considering this as one of the easy question. This I think was doable. Just equate the volumes. Therefore, counting this question. This also again was a basic formula based questions and the calculation is also not very difficult. Here, again, there is a chance of time, we end up taking time because we might find R and then start finding H without realizing that we just have to add a value. Because of that, the time taken will increase significantly and chance of error will also increase. So therefore, I'm not saying one of the easy 6 questions, not counting this. Here also, if we can get confused while finding the area of the drainlet and the calculation can take a lot of time. Therefore, not counting this as one of the 6 easy questions. This was straightforward, equate. And then finally, this one also just find the cube and add. And the only thing is don't call the sphere a cube. But yeah, so easy question. So definitely attempting this one as well. Overall, my attempt will be 1, 3, 5, 6, 9, and 10, which will give me net 6 correct questions.